Hi dear students, I am Amit Ajmani and today we will be taking up the next topic, that is acceleration. Now till now in this chapter we have studied about the object moving with a uniform speed or a non-uniform speed, the distance travelled by the object, the displacement of the object, right? Now if an object is travelling along a straight road or a straight path, right, and the speed of the object is uniform, there is no change in it, right. So therefore there is no change in its speed or velocity. But if, let us say, an object is not moving on a straight road, or an object or a vehicle is moving with non-uniform motion in a crowded place where there is a lot of traffic or congestion, so over there the speed or velocity of this particular object is going to change, and this gives us a new physical quantity which we call as acceleration or acceleration, the way you want to pronounce it, right, acceleration or acceleration. Now what exactly is acceleration? Acceleration is the rate of change in velocity. Now we know that when we talk about velocity, we have two varieties or types of velocities, that is initial velocity of the object as well as the final velocity. First of all, let us be acquainted with what exactly these initial and final velocities are. Initial velocity means the speed or the velocity which the object was initially moving, right, and this is represented by small u, whereas final velocity is the speed or the velocity with which the object is moving after a specified time when we observe it. It is represented by small alphabet v. Fine. And when we talk about change in velocity, that simply means change in velocity can be expressed as final velocity minus initial velocity. Whenever we are talking about a change in a particular thing, we say that what was the initial value, what is the final value, and the difference between them is the change, right. And I have already told, I am repeating it, whenever it comes rate of simply means per unit time. Per means divided by. So that means whenever we are talking about rate of, it simply means you have to divide it with time. So now when I am talking about the definition of acceleration, I can mathematically express it as rate of means divided by time taken. Change in velocity is final velocity minus initial velocity. So when I am talking about acceleration is equal to change in velocity per unit time, or change in velocity divided by time, or final velocity minus initial velocity divided by time. This acceleration is represented by small a. Final velocity, as we have studied right 2 minutes back, small v representation. Initial velocity is represented by small u, and time is represented by small t. So this is the mathematical representation or the formula for acceleration, right. This is quite important. Now when we are talking about velocities, we know that the SI unit of velocity, whether it is initial velocity or it is final velocity, the SI unit is meter per second, and of course we know the SI unit of time is second. So meter per second gives us meter per second square. This is the SI unit of acceleration. Quite important, one marker question. What is the SI unit of acceleration? It is meter per second square. It may also be expressed as meter per second square, or we can also write it to be meter second minus 2. Minus 2 because this 2 power, it is in denominator. When it comes in the numerator, we know that it is converted into negative power. So, whether we write like this, putting a slash, or dividing it by second square, or we are writing second minus 2, or inverse, we call it inverse power. So, this is one or the same thing. This is the SI unit of acceleration, right? Fine. Now, there are a few things that we need to relate. Acceleration we have understood, right? That acceleration is the rate of change in velocity of an object. Now, when an object is moving in uniform motion, that means the initial velocity and the final velocity is same. Initially also, let us take an example. The body is moving at a speed of say 15 kilometers per hour. Again, continuously it is going with the same speed of 15 kilometer per hour, and again with the speed of 15 kilometer per hour. The initial velocity with which it was moving and the final velocity with which it is moving, it is all together the same, and it is moving in a straight line. So, there are two conditions. One is the body should be moving in straight path. Another is if the body is in uniform motion, then we related and saw that the change in velocity is 0. The change in velocity will be 0, and if we say acceleration is final velocity minus initial velocity divided by time taken, this is change in velocity. If this is 0, that means the acceleration of the body is also 0. Fine. So, the body is not accelerating, the body is not showing any acceleration motion. Fine. Next, let us see. If there is a non-uniform motion, then we say that the change in velocity is not 0. That means there are now two options that we will relate. What are the two options? Let us see. Let us take an example that a body initially is moving at a speed of say first part is 50 kilometers per hour. We will relate it as the initial velocity, that is represented by small u. After let us say 10 seconds or 5 seconds time, we again calculated its velocity represented by v, or the final velocity. Now, there are three options. First option that we have already discussed, that the velocity is same 50 kilometers per hour. The second option is maybe the velocity is increasing, the car is speeding up. Let us say now the velocity is 60 kilometers per hour. Right. The first case that we had taken was the velocity remains the same, that is 50 kilometers per hour. The second case we are taking is that the velocity now is 60 kilometers per hour. But there is another possibility. That possibility is that maybe because of some traffic, because of any traffic signal, or because of any reason, this particular car applies brakes and it slows down. And if it slows down, then in that case, now its final velocity, let us say, decreases, and it is less than what initially it was traveling at. Right. So, there are three options. Let us assume all the three options. We say that acceleration is change in velocity upon time, or v minus u upon t. Got it? If our initial velocity is 50 and the final velocity is also 50 regardless of the time, the acceleration becomes 0. Right? This is what we have already studied. Let us see the second and the important case. The second case is कि now acceleration is final velocity is 60 kilometers per hour, minus initial velocity was less, that is 50 kilometers per hour in whatever time. So now we have got acceleration is 10, which is positive value. Why it is positive? Because the final velocity is more than that of the initial velocity. So when the value of acceleration comes out to be positive, and when it will come? When the final velocity will be greater than the initial velocity, then we call it a normal acceleration, or we also call it positive acceleration, or in other terms, in layman terms, in normal day to day term, we say that the object is speeding up, right? The speed is increasing. Fine. Now quite importantly, let us take the third possibility, that our initial velocity u is 50, that is the u, and the final velocity is 30 kilometers per hour in whatever time, 2 seconds, 5 seconds, whatever, right? Now because the final velocity is less and the initial velocity is more, our acceleration comes out to be minus 20 upon t. This minus sign represents that the final velocity is less than the initial velocity, or other way of saying it is that the initial velocity now is more than that of the final velocity. And when this is the case, then initially in the second case we had said that it was positive acceleration or simply acceleration, but when the value of acceleration is coming out to be negative, then we call it a negative acceleration, or we give it another name, and that another name is retardation. So what is retardation? Retardation is simply negative acceleration, and retardation is simply minus a, or other way around, when a is in minus any value. The SI unit is same, everything is same, meter per second square, simply there is a minus sign, simply it represents that the initial velocity was more and the final velocity was less. And when will it happen? It will always happen whenever there is some opposite force is acting. That opposite force is maybe due to the wind, when for example we are pedaling a bicycle, after pedaling 10 or 20 times, if I leave pedaling and the air is going opposite to me, then that air that will create an opposite force and it will tend me to slow down. Or when we stop pedaling, the tires which are basically in contact with the road or the surface, that surface, when two surface combine or they are in contact with each other, we know that there is an opposing force, that is force of friction, that also slows us down. Or whenever brakes are applied, when you apply brakes, then also the speed is going to slow down. So in all the cases, the final velocity will be less than the initial velocity, and hence it will be negative acceleration, and it is also known as retardation.
Now subscribe to Bright Tutee course at ₹1 per day only. Download Bright Tutee app from Play Store and get the online courses prepared by competent and experienced teachers for different education boards of classes 6 to 10. Bright Tutee courses are available for the subjects of Math, Science, Social Science, English and Hindi in English and Hindi medium. Bright Tutee follows 3-step approach, that is learning, assessment and exam preparation. In learning, topic-wise video lectures with explanation of concepts and discussion of textbook examples and questions are available with the solutions. In assessment, topic-wise online MCQ test, practice assignments and chapter-wise question bank are available with the solutions. In exam preparation, previous year's question papers, sample papers and model test papers are available with the solutions. Sign up today on Bright Tutee and avail your courses at affordable prices.